When using an isolated power source like a truck-mounted generator, it lacks a direct connection to earth ground. A person who is wet or grounded who touches the frame of a tool, some current may flow through the body to the earth, which results in a tingle. The human body has resistance, and current chooses the path of least resistance. Grounding the truck-mounted generator establishes a connection to earth ground, potentially creating a ground loop if an alternative path for current to return to the generator exists. For instance, consider a drill submerged in water connected to earth ground. Current could flow through the water, through a person, and back to the generator through this new ground connection, resulting in a hazardous shock. Ground fault circuit interrupters, GFCIs, enhance safety by detecting imbalances in current flow. Should a GFCI detect more current leaving the circuit than returning, it will trip, cutting off power and preventing potential shocks from ground faults, such as a drill dropped in water. However, GFCIs may not trip if current flows through a path including a person's body, as in the case of a tingle. To reduce risks when using truck-mounted generators, 1. Use insulated tools, which means provide operators with insulated tools to reduce the risk of touching grounded surfaces. 2. Ensure proper grounding, which means ground all equipment not already grounded, such as saws and drills. 3. Use isolated power sources wherever possible, avoiding grounding the generator frame. 4. Test for ground faults regularly using a ground fault tester. 5. Train operators, educating them on potential hazards and proper safety procedures. Balancing the risks of ground loops against the benefits of reducing tingles is important. In environments with high water risk, maintaining generator isolation may be safer. With proper grounding and safety measures, the risks of truck-mounted generators can be minimized. To delve deeper into generator grounding, let's explore various aspects. Firstly, understanding bonding and grounding requirements is crucial. Bonding ensures that all metallic parts of an electrical system are connected, creating a low-impedance path for fault current. Grounding, on the other hand, connects the system to earth, providing a reference point for voltage and helping to stabilize the system. Secondly, the National Electrical Code, or NEC, provides detailed guidelines for grounding and bonding. NEC Section 250 covers grounding and bonding requirements for electrical systems, including generators. It specifies the size and type of grounding conductors, as well as the methods for connecting to ground. Thirdly, portable generators often have a floating neutral, meaning the neutral conductor is not directly connected to ground. This design is intended to reduce the risk of electric shock, as it prevents a direct path for current to flow to ground. However, it also means that the generator is more susceptible to voltage fluctuations and can be more difficult to ground properly. Fourthly, when grounding a portable generator with a floating neutral, it's important to establish a solid connection to earth. This can be achieved by driving a ground rod into the earth and connecting it to the generator's grounding terminal. The ground rod should be made of copper or galvanized steel and should be at least 8 feet long. Fifthly, the size of the grounding conductor should be based on the size of the generator's output conductors. NEC Table 250.122 provides guidance on the appropriate size of grounding conductors for various conductor sizes. Sixthly, it's important to ensure that the grounding conductor is properly connected to the generator's grounding terminal and to the ground rod. The connection should be made using a listed connector and should be tightened securely. Seventhly, when using a generator to power multiple pieces of equipment, it's important to ensure that all equipment is properly grounded. This can be achieved by connecting the equipment's grounding conductors to a common grounding point, such as a ground bus bar. Eighthly, ground fault circuit interrupters, or GFCIs, are an important safety device for generators. GFCIs detect imbalances in current flow and trip the circuit if a ground fault is detected. This can help to prevent electric shock and can protect equipment from damage. Ninthly, when using a generator in a wet environment, it's especially important to use GFCIs. Water can provide a path for current to flow to ground, increasing the risk of electric shock. Tenthly, regularly inspect the generator and its grounding system for any signs of damage or wear. Replace any damaged components immediately. 11. Consider using an isolation transformer. An isolation transformer provides electrical isolation between the generator and the load, reducing the risk of ground loops and electric shock. Isolation transformers can be particularly useful in sensitive applications such as medical equipment or audio systems. 12. Be aware of the potential for backfeed. Backfeed occurs when power from the generator is fed back into the utility grid. This can be dangerous for utility workers and can damage equipment. To prevent backfeed, use a transfer switch that isolates the generator from the utility grid. 13. Consider the impedance of the earth. The earth is not a perfect conductor, and its impedance can affect the flow of fault current. In some cases, it may be necessary to use multiple ground rods to reduce the impedance of the earth. 14. Consult with a qualified electrician. Grounding and bonding can be complex topics, and it's important to consult with a qualified electrician to ensure that your generator is properly grounded. They can assess your specific situation and recommend the best grounding solution for your needs. 15. Remember safety first. Always follow safe work practices when working with electricity. Wear appropriate personal protective equipment, such as gloves and eye protection. Never work on electrical equipment while it is energized. 16. Use a multimeter to verify grounding. After setting up the grounding system, use a multimeter to verify that the generator frame is properly grounded. Measure the voltage between the generator frame and a known good ground, such as a metal water pipe. The voltage should be close to 0 volts. 17. Understand the difference between system grounding and equipment grounding. System grounding connects the neutral conductor of the electrical system to ground, while equipment grounding connects the non-current carrying metal parts of equipment to ground. Both types of grounding are important for safety. 18. Consider the type of soil. The type of soil can affect the effectiveness of the grounding system. Sandy soil is less conductive than clay soil, so a longer ground rod may be needed in sandy soil. 19. Use a ground resistance tester. A ground resistance tester can be used to measure the resistance of the grounding system. This can help to identify potential problems with the grounding system. 20. Follow manufacturer's instructions. Always follow the manufacturer's instructions when installing and using a generator. The manufacturer's instructions will provide specific guidance on grounding and bonding. 21. Be aware of local codes and regulations. Local codes and regulations may have specific requirements for grounding and bonding. Be sure to comply with all applicable codes and regulations. 22. Consider using a surge protector. A surge protector can help to protect the generator and connected equipment from voltage surges. Voltage surges can be caused by lightning strikes or other electrical disturbances. 23. Regularly inspect the ground rod and connections. The ground rod and connections should be inspected regularly for corrosion or damage. Replace any corroded or damaged components. 24. Be aware of the potential for static electricity. Static electricity can build up on the generator frame, especially in dry environments. This can cause a shock if someone touches the generator frame. To reduce the risk of static electricity, ground the generator frame and wear anti-static clothing. 25. Consider the use of a grounding electrode conductor, or GEC. The GEC connects the grounding electrode to the electrical system. The size of the GEC should be based on the size of the service entrance conductors. 26. Understand the concept of impedance grounding. Impedance grounding uses a resistor to limit the amount of fault current that can flow to ground. This can help to reduce the risk of arc flash and can improve the stability of the electrical system. 27. Consider the use of a separately derived system, or SDS. An SDS is an electrical system that is not directly connected to the utility grid. Generators are often used as SDS. The grounding requirements for an SDS are different than the grounding requirements for a system that is connected to the utility grid. 28. Understand the difference between a grounded system and an ungrounded system. In a grounded system, the neutral conductor is connected to ground. In an ungrounded system, the neutral conductor is not connected to ground. Grounded systems are more common than ungrounded systems. 29. Consider the use of a high resistance grounding system. A high resistance grounding system uses a high value resistor to limit the amount of fault current that can flow to ground. This can help to reduce the risk of arc flash and can improve the stability of the electrical system. 30. Be aware of the potential for touch voltage. Touch voltage is the voltage between the generator frame and ground. Touch voltage can be dangerous if it is high enough to cause a shock. 31. Consider the use of a step potential mat. A step potential mat is a conductive mat that is placed around the generator. The mat helps to equalize the voltage gradient in the area, reducing the risk of electric shock. 32. Understand the concept of arc flash. Arc flash is a dangerous electrical explosion that can occur when there is a fault in the electrical system. Arc flash can cause serious burns and other injuries. 33. Consider the use of arc flash protection. Arc flash protection includes measures such as using arc-resistant equipment, wearing arc-rated clothing, and implementing arc flash safety procedures. 34. Be aware of the potential for lightning strikes. Lightning strikes can damage the generator and connected equipment. To protect against lightning strikes, use a lightning protection system. 35. Consider the use of a transient voltage surge suppressor, or TVSS. A TVSS can help to protect the generator and connected equipment from voltage surges caused by lightning strikes or other electrical disturbances. 36. Regularly test the GFCI protection. The GFCI protection should be tested regularly to ensure that it is working properly. The GFCI can be tested by pressing the test button on the GFCI receptacle. 37. Be aware of the potential for stray voltage. Stray voltage is a low-level voltage that can be present on metal objects such as water pipes or fences. Stray voltage can be caused by a variety of factors, including nearby power lines or faulty electrical equipment. 38. Consider the use of an equipotential plane. An equipotential plane is a conductive surface that is connected to ground. The equipotential plane helps to equalize the voltage gradient in the area, reducing the risk of electric shock. 39. Understand the concept of bonding jumpers. Bonding jumpers are used to connect metal parts of equipment to the grounding system. Bonding jumpers are important for ensuring that all metal parts of equipment are at the same potential, reducing the risk of electric shock. 40. Consult with an electrical engineer. Grounding and bonding can be complex topics, and it's always a good idea to consult with an electrical engineer to ensure that your generator is properly grounded and bonded. They can assess your specific situation and recommend the best grounding solution for your needs. 41. Always prioritize safety. When working with electricity, always prioritize safety. Follow safe work practices and wear appropriate personal protective equipment. Never work on electrical equipment while it is energized. Understanding these aspects of generator grounding can help ensure a safe and reliable power source. Remember to consult with qualified professionals and adhere to local codes and regulations for optimal safety.